Good afternoon, everybody. A big thanks to those of you who've joined already. I'm just going to give it another minute or so just to let the last couple of people join, and then we'll get underway if that's all right. Thank you. Okay, so hello everybody. I'd just like to once again say a big thank you for your time today. My name's Josh Fulford. I work in the business development team here at NotSoSecure, and I've been fortunate enough to have been in the company for around about 2.5 years. Now, I'll shortly be handing over to Anthony Webb, who will be taking you through our infrastructure hacking webinar, and this directly correlates to our advanced infrastructure hacking course, which I will touch upon briefly very soon. Ant is a associate director here at NotSoSecure, and he has a real wealth of experience as well as extensive knowledge in his subject field, which he'll be sharing with you very, very shortly. But actually, first and foremost, he is a pen tester, and one of the biggest advantages we have when it comes to our training is that it's delivered by real-world pen testers. And this is great when it comes to interactive sessions and our students maximising what they can really extract from our courses. So, as I just mentioned, Ant will be taking you through all things when it comes to security and your infrastructure very, very shortly. But first, I just wanted to give you a very brief a bit of background knowledge around ourselves as a company, what it is we do exactly, and why that can be of some interest to you. And hopefully that's why you're listening to this webinar here today. Now, as you can see, NotSoSecure is a traditional ethical pen testing and training provider within cybersecurity. Or put simply, we hack and we teach. We were acquired by Claranet a couple of years ago, and as you can see by our operating logo there, this has been hugely beneficial for us for a multiple number of reasons. And one of those is it's allowed us to offer a more managed service as well. So not only do we hack and we teach, but we can actually look at proactively protecting your data as well. And number two, it's actually allowed us to integrate within a company that specialises specifically in managed services, and that's great for us as it allows us to drive thoughts around cybersecurity right at the very start in a much more of a proactive way rather than reactive. And with that, we can now offer cybersecurity services as a continuous solution for you. And as you can see there, these proactive services are CST or continuous security testing, as you can see on the right-hand side of your screen there. But we also offer MDR, which is managed detection and response. And also in conjunction with that, we do endpoint detection response services as well. Again, then on the right-hand side there is where you've probably most likely come across our name. We're actually officially Black Hat's biggest trainer, and back at our last on-site attendance in 2019, we trained over 600 students. I had the pleasure of being there myself, and hopefully later on this year and moving forward progressively into the future, we can look at pushing those numbers even higher once more. But for all of this, it's our in-depth training where we really come into our own, and our courses range in difficulty and complexity. But we certainly have a course that's right for you that will fit your needs regardless of your prior technical understanding. These courses range right the way through from beginner level hacking 101 courses right the way through to advanced infrastructure and web hacking, which certainly links to why you've joined today. Then we have our more specialist courses such as DevSecOps, as you can see on the screen, AppSecOps, and also application security for developers, sorry. The latter simply teaches individuals how somebody externally might think, and it puts them in a hacker's shoes so they're much better equipped to deal with real life threats. And all of our courses will either fall under an offensive or defensive point of view. We give both sides to how a hacker might think. And again, our training combats the cyber skills gap. The most single-handed threat to any organisation at the moment is certainly the people. And this is where we teach how to be more compliant and secure by understanding more modern external threats. And then finally, our pen testing services look at, or they take a look at, sorry, your security posture from a third-party perspective. And whilst being able to mark your own homework is great, you certainly won't be the one marking it when it comes to a real exam. If your company is a ship out at sea and there's a potential for a storm at any given moment, we'll just simply be looking at what's tied down and secure and what's not, what's safe and what isn't. And we'll be honest with you, when it comes to post-test reporting stage, we'll sit down with you and take a look at how to mitigate these vulnerabilities. And there's a lot of consultancy work that we do for free, such as free attack service appraisal, post-test debrief calls and reports, just to name a few. And why do we do that? Well, we just want to help you. We just want to be the security provider that you can trust. And if there's anyone listening who might want us to have a look at something, or simply would just like some security advice, just please do get in touch. We really do want to help you on your cybersecurity journey, and that's applicable to individuals as well as corporate customers potentially listening today as well. So that's pretty much all from me. But just before I quickly pass over to Ant, we do have a free training course that's that you can win. All you need to do is just speak to one of us about potential training or pen test requirement, whatever that might be, and we'll give a little bit of further information regarding how you can do this at the end of the webinar. But without any further ado, I'll pass over to Anthony, who will take you through the webinar.
Thank you very much. So yeah, just echoing the thank you for coming thing, as I must. Who am I and why am I here? Well, my name's Anthony, or Ant, whatever. I'm an associate director here at NotSoSecure. As Josh just said, I am a pen tester. That is what I do. Generally, I specialize in the sort of infrastructure and cloud infrastructure side of that. As a pen tester, picked up a bunch of letters, rather not go on about them. I'd rather just tell you I've been a geek forever. Started coding on a BBC Micro way back in the early 90s, if anyone is old enough to remember those, and have been kind of breaking stuff ever since, even occasionally make things work again afterwards. Also delivering a huge amount of training. So in the last few years, I've been, well, prior to all of this, I've been at almost every Black Hat event in the last, I think it's 4 years. I think I've missed 2. If we include virtual attendance, I think it should count. But other various different conferences, classroom trainings, in-house trainings, all that kind of stuff. Do loads and loads and loads of that too. Theoretically, I'm roughly 50-50 these days. Obligatory Twitter handle. I'm not a prolific tweeter or anything, but if you do want to talk shop, I'm always willing. So it's as good a place to reach me as any. So it's there because that's just what we do. But let's get more onto why we're here, or why you're here. The reality is there are hundreds of thousands of known vulnerabilities in what is a ever increasingly diverse software and hardware set of systems in use globally, especially with the way the workplace has sort of diverged now, with more and more people working from home or whatever, and workplaces accepting that that's kind of a reality now. As an attacker, which is theoretically what I am, I'm one of the good guys, but still one of the bad guys. We can't claim to understand all of them. It's not realistically possible that we could have this sort of broad depth of knowledge in all the different possible ways we could break in. And so once upon a time, a lot of attacks were sort of opportunistic. These days, a seasoned foe has learned to adapt to what they find. So in the world of APTs, advanced persistent threats, where we see an organization targeted until a way in is found, rather than just knowing about a vulnerability and looking until we find an organization vulnerable to it. Attackers adapt much more than they ever used to, and they will figure out how to exploit the flaws that exist rather than just relying on existing knowledge. So as a defender, defending your environment from these malicious actors basically requires an understanding of how they're going to go about doing that. What is it they will do? How will they look at your infrastructure, and how will they figure out where those vulnerabilities lie? It's all well and good that you've probably got a better internal view of what those systems look like, but that doesn't mean you understand what they look like to them. Hence the name for the webinar, Through an Attacker's Eyes. So our goal is to take you through some of what we consider to be some of the more interesting scenarios that we've seen. Everything that we talk about is something that we've seen in real pen test engagements or in real case studies of genuine vulnerabilities. Some of these we consider to be the neat, the new, and the ridiculous. So the shameless plug, of course, that goes with that free place that we're offering is that all the demos I'm going to show you are directly lifted from our actual lab environment, that as an attendee of our courses, you get access to hands-on attack all of these vulnerabilities. So while in some sense they may look a little bit contrived, I assure you, even though they are from a lab environment, they are all based on 100% real stuff that we've actually seen out there. So without further ado, let's do a little bit of this. I don't know, making skulls and codes or something. I should introduce you to what we call our art of hacking methodology. So this is a kind of a distilled version, I suppose, of what any given hacker, malicious or otherwise, might consider their approach to an engagement. So we would all probably have differences in our methodology, but if you were to take a sample of a whole bunch of hackers and a whole bunch of pen testers and say, let's break this down into 5 steps, this is pretty much what you'd end up with. So any pen test is always going to begin with some enumeration and information gathering. Again, as a pen tester, I'm very rarely given that much information. I generally know a little bit. I'll know the name of the organization, maybe a few endpoints, I'll have the name of a contact, but beyond that, I probably won't know very much. The same applies as a malicious attacker. You know who you're attacking, but that's probably about it, to be honest. Everything else is going to be down to finding stuff out. So this includes both passive information gathering, which basically means Googling, using freely available resources to learn as much about the organization, about your target, without directly interacting with that target. So they can't possibly know that you're researching them if you're just Googling them or looking them up on GitHub or whatever. It also involves the sort of scanning and discovery phase, where maybe we start trying to look at your visible endpoints, the external surface area of your networks, servers that you've got spun up that are facing the public, those sorts of things. And that's a bit more hands-on, a bit less passive. We might do a bit of service discovery and so on. We then move on to what we call identification of vulnerabilities. We are discovering, listing and analyzing all the different services that are accessible, all the resources, both in terms of computers and human resources, and working out where those vulnerabilities may lie. As I'm sure you know, an awful lot of attacks start with a human element, and so they are just as important and just as relevant, but it's just about discovering what exists, what we may be able to do with that information, and again, learning as much as we can and just starting to rank those vulnerabilities in sort of how confident we are we're going to be able to exploit them. The exploitation phase involves trying to get some sort of initial foothold. So that's going to involve attacking maybe exposed and out-of-date services or misconfigured services and trying to get some sort of initial access to some systems, or going phishing and hoping to come away with some access, but generally speaking, not particularly high privileges or not access to a great deal of systems. Sometimes we get lucky. Sometimes we get root access to some server that leads us straight into a file share and end up with domain admin on the first day. But a lot of the time, that's not the case. So using that initial exploitation phase, we're just trying to get what access we can before we move into post-exploitation. What that basically means is, as the name suggests, everything that comes after. So there's an awful lot of expanding access, trying to build upon the initial foothold we've got to expand further into the network or to increase our privileges on the devices we have got access to, and effectively to try and gain access to more. I'll hopefully be in a position where we've got multiple privileges by this point and access to multiple systems, and then it's just about using all of those available privileges to discover everything there is to see. And ultimately, we're going to go back to the start in order to begin enumerating and information gathering again, because the chances are we can now see more than we could before. We know about more systems than we knew about before. We know more data than we knew before. Maybe we've exposed network shares that contain sensitive information. Maybe we found about some internal networks that we didn't previously know about, or we found some way of pivoting into them. And so it's an awful lot of enumeration again, identifying vulnerabilities in those new systems, exploiting those vulnerabilities, expanding that access, looking around again, and so on. And we do tend to go around and around and around this. So this isn't a one pass thing. There's very much a cycle to a pen test. So there are lots of different potential interesting scenarios to explore, and as you can see, this is basically the syllabus for the AIH course that this links up to. And so I've just highlighted a few areas that we're going to take a look at, a small subsection of each of these areas. So, you know, it's a 5-day course. There's only so much we can do in an hour, but I'm going to try and take us on a pit stop tour through a few of these if I can. I'm known for running over, so I'm going to warn you of that in advance. But let's start with OSINT, or Open Source Intelligence, which may be a name you've heard. It basically means gathering data from publicly available sources. As I mentioned, basically Googling. Web 1.0, once upon a time, was a world where you had information producers, the organizations, and information consumers, the rest of us, and we accessed websites and we learned stuff. Stuff that was shared was what was intentionally shared, and that was more or less it. In the world we're in now, Web 2.0 plus, I think some would argue we're on like 3.5 or something. I don't know where these numbers come from. We know that everyone is constantly sharing, and we know that there's an awful lot of information out there. And that makes information gathering very, very easy in some respects, but also it's the complexity of that information overload. So some important sources for data may well simply be the search engines. You've got Google, you've got Bing, you've got dedicated engines for hardware, so Shodan and Zoomai are some examples of those. You've got public directories, so maybe domain registrars, company registrars, these sorts of tracking organizations. You've got social media, Facebook, a horrific rabbit hole. If you do want to go spear phishing, looking after specific targeted phishing exercises against very specific targets, and yeah, you can learn a huge amount about an individual and about their interests or their mother's maiden name and first pet's name, and use that to trick them into sort of engaging with you further. If you know someone's into stamp collecting and you claim to have a rare stamp, they're far more likely to engage than if you just say, I'm a Nigerian prince and I've come into a great deal of money. LinkedIn, probably arguably a better resource if we're looking, for example, we can list out everyone who cares to admit that they work for a certain organization. And if we've already got an idea of their username formatting, which is very often based on some combination of first name, last name, we can go a great deal further with that kind of information. And then there's things like public pastes. So pastebin, notoriously difficult to search and index, but pretty much every breach that's ever taken place and been made public is probably on pastebin somewhere. And you can grab that data and potentially find existing breaches of your organization's employees' details. So for example, we went on GitHub and we searched for the term .files. These files are effectively your config files on a Linux host. And sysadmins have a bit of a habit a while back of sharing them, trying to show off their cool customized command prompts and things like that. In amongst those may well be authorization keys and things like that. So lots of stuff. You can see there were 215,000 results nearly. Just behind here, there is that's admittedly a few generations ago now, but a Facebook person profile that we were not friends with, and we've got their date of birth, we've got their personal website, their hometown, their relationship status, where they've studied, where they've worked, and so on and so on. And the last one here is on Shodan, and we're able to look for hardware. In this case, we've gone for Cisco devices with the Telnet port exposed to the internet in the US. And again, quite a few results when you consider what a horrific security breach that is. So just a bit of an example here, we're going to look up an organization called NotSoFruity. So NotSoFruity.com, they're a software solutions company, and we can learn a fair bit about them very quickly. We've Googled them, we've established that there's a person there called Robert Birdie, and it looks like their email address is a first name, last name. We've got a link to their GitHub page, which we can check out straight away. And we can see their website, we can see they've got a test repository. This appears to be how their site is hosted using GitHub.io. Everyone's got a test repository, right? And then they've got a list of people, and we've got two more names now, Bob Stewart and John Smith. Bob Stewart appears to have been born in 1985, I guess. John Smith maybe was in 1990, who knows? And we can confirm they've got admin NS32 with nothing going on. We've got Bob Stewart, and again, email address format confirmed, and a repository. Seems to be a PowerShell email server tool. And we can look inside, and actually Bob's been quite sensible. We're using the get credential commandlet, which I thought I highlighted it, apparently I didn't when I recorded this, which basically allows you to have credentials input rather than storing them in a script. But if we look back at its history, it was once upon a time a Perl script before it was a PowerShell script, and at some point Bob Stewart submitted some credentials as part of a commit. And this stuff, so the way that Git works is permanently on the internet now. There's very little you can do to get rid of that without deleting the whole repository and starting again. So who knows, maybe a bit of password reuse, maybe we'll find out later. Meanwhile, John Smith, again, confirmed the email address format, has a bunch of repositories. A lot of them are just forked from elsewhere, but this one, .files, looks interesting. And sure enough, we've got SSH key pair and a config file that seems to suggest, when we go into it, that he uses that key to access a Jenkins server. So maybe more on what Jenkins is in a minute. But let's see if we can connect to this using that private key. So I'm going to configure it locally on a machine. I'm just going to take the exact configuration file that we've stolen, stick the private key, save those, and attempt to connect. And because we got this banner, we know for certain that those credentials are valid. We would not get this banner if those credentials weren't valid. However, we do get an error, interactive Git shell is not enabled. And while that is an error that kicks us out, it is a clue that points us towards something else. So if we take a look at this host, it turns out it also has a website hosted, and it says something about creating test builds for websites. It links to a few of the sites we've already seen, but also one to a build server. We've got some directories where we seem to commit to, and the build server is called Jenkins, and there seems to be maybe a hint to where we're going to go next with this. So let's talk about your continuous integration, continuous deployment or development, depending on who you ask, pipeline, and how we can exploit it. The basic process is, and this is very, very simplified, programmers commit code to a repository. They will merge that at some point into a Git mainline repository. They will use a CI server, perhaps like Jenkins, to build and deploy that code to some sort of test bed or production environment, who knows, after some test cases have been run, and ultimately the application is eventually going to be deployed to production. So from an attacker's perspective, if we can gain access to that dev machine, we can potentially gain access to source code and indeed to credentials for the repository. If we gain access to the repository, we can get at the source code there. If we can gain access to the CI server, we can potentially plant our own backdoors and perhaps even get that code deployed somewhere, whether auto deployment is enabled, or if we can deploy unauthenticated or by some other means. And if we get to the production server, we can potentially get an instant compromise if any of those previous steps have got flaws. So going straight from where we just stopped and looking at this Jenkins host, it appears that a Git shell was not enabled. And if we look at the one project, which we can gain access to completely unauthenticated because it's intended to be an internal server, we have a project called Deploy Web, which clones from a local Git repository called bear.git and commits it to the web server. So given our SSH config appeared to be to Jenkins as John Smith, let's see what happens when we do a Git clone. Using SSH authentication, we were able to gain access to that bear.git that was stored on that host, and we've now got a local copy of it. We can quickly confirm that by looking at the index page, which says testing the PHP server setup. And if we look at the local copy on port 80 in bear, we've got that exact same text. So that suggests that that is where that deploys. So let's see if we can commit our own. We're just going to go with a quick test first, save that. You need to do a git add followed by a git commit. And then we'll do a push. We then hop back to Jenkins, hit build because it lets us, again, unauthenticated. And we can check the console output and see that our script has been found. And if I now browse to shell.php, there's my text. So what if we stick a quick web shell in there? Go with the simplest web shell you've ever seen. It just accepts a parameter called cmd as part of a URL, and it feeds it to the PHP system function. Same process. If you do a git status, you can always find out where you're at if you're not sure, and it actually tells us a quick shortcut. So we can do a git commit -a-m and push. And build. Don't usually get ahead of myself on these things. I sped this up. Hit refresh. That disappears because we need to give that parameter. So we're going to add a command into the cmd parameter, and we can get our command run. I've gone with ID and got a command run. You could go with something else, maybe cat out etc password or something like that. And we're able to access system files and who knows what else. You can stretch this, by the way. You can actually get a full reverse shell off a host in exactly the same way. However, let's move on to totally different attack, different sort of vulnerability. We're going to look at deserialization. So first off, I should probably introduce what serialization is. It's basically a way of translating data from object form into sort of byte stream. So we use it when we're going to transmit data as part of an object-oriented application. So we take our object, we serialize it into a byte stream. It's not encryption or anything like that. It's not meant to be security. It's just a sort of an encoding, I suppose. And we might store that in memory or as a file. We might stick it in a database. We might transfer it across the network. Whatever we're doing, where we don't want it to be an object, we don't want it to be treated as an object. We just want it to be treated as a stream of bytes. And then at the other end, at some point, it's going to be deserialized and returned back to its object form. And the problem arises at this point, where that object form gets passed during the deserialization process, we may well be able to get code run. So pretty much every language supports serialization. So Java, PHP, .NET, COM, Ruby, Python, basically anything object-oriented will have a function along these lines. Some call it serialization and deserialization or unserialization. Some call it marshal and unmarshal. Some call it pickle and unpickle. It doesn't really matter what they call it. It behaves in the same way. Almost all of them have had bugs in deserialization routines leading to remote code execution, very often as an unauthenticated application user. So just to list a few, the first sort of major finding was in 2015 in the Java Commons Collections 1 library, which meant it affected an incredible number of applications because Commons Collections 1 was, you can probably tell by the name, quite a commonly used library. So it affected WebLogic, WebSphere, JBoss, Jenkins, OpenNMS. And the nutty thing about this was it wasn't taken seriously because a proof of concept wasn't released. So it was discussed in January as being a serious vulnerability, but it wasn't until the proof of concept was written in November that suddenly people started taking it seriously and a fix was actually released. From that moment onwards, there was an absolute avalanche of deserialization vulnerabilities. It's now been found in Commons Collections 1, 2, 3, 4, 5, and 6. It's been found in Python, Ruby, .NET, Microsoft COM. It's been found absolutely everywhere, and they're still finding them now. There was a new deserialization vulnerability just last year. I don't know if one's been found yet this year, but I certainly wouldn't put bets against it. And some more easy to attack than others. Some of them you don't need to even attack using a serialized payload. Some of them you can just attack with plain text. So if you're looking at a Java serialization, you will probably find that you're looking at a serialized object stored in base 64. So you can actually look for a telltale sign R00AB at the start of the string. And if you see one of these anywhere, this is just in the response from an application, this is from a WebSphere server. We've just sent a straight up query to it, no additional text, no sort of clever no clever attacking packet or anything like that. We've literally just sent a query and it's come back with this header that contains a fault string, which appears to be a serialized object. And it turns out you can overwrite that and pass it back and it will deserialize it. And if you put some code in that object before you serialize your attack, when it's deserialized, your code will end up getting run. It's literally as simple as that. So to serialize our payload, we can use a tool like NotSoSecure, which is basically a proof of concept tool that generates serialized payloads. And it looks something like this. So we're going to attack a node website here. We're going to register for this site and it says, hello, welcome. And if we look in a tool called Burp Suite, which is an attacker proxy, which allows us to view our requests and responses, we can see that the form is submitted with a CSRF token. There's some irony here because a CSRF token is a cross-site request forgery token. It's actually a protective mechanism that exists to prevent you from tricking people into submitting forms on other sites. So without CSRF tokens, I can trick you into submitting a form on a site that you are authenticated to. It results in you making changes to your profile, maybe change your password, something scary like that. So these tokens are there to prevent it. But if we take this token on this particular framework and we decode it, it turns out that it is literally base64 encoded some data, username AWH in this case. And it turns out that if I overwrite that with my own code, base64 encode it, not even properly serialized, it's just base64 encoded, I'm asking it to reach out to me and attempt to retrieve test from a web server running on my host. I take that long code that I've just created, I set up a listener so I can see if I receive this request, and I resubmit the request using a tool in Burp Suite called Repeater. which just takes my existing request, allows me to make changes to it and resend it. So I'm going to send that now. We can see that we've got a 200 OK, but over here we've received a wget request, which means that vulnerable system at the other end just did whatever I told it to, because I put it in a serialized payload. Literally as simple as that. So I could then go ahead and set myself up a new listener. I'm going to create a shell using Node.js shell Python tool. We're just going to create a shell which I can then serialize. That's going to reach back out to me. So I just grab this output here, stick that in my decoder, replacing the original function, re-encode it, grab that, send it back to repeater, hit send on this, and over here I've received a connection and I'm running as root on the victim system, just like that. That's how easy some of these are to exploit. Now let's say you get code execution of some kind on a victim system. One of the most widely known open source web servers is called Apache. It is it's kind of the basis for the XAMPP and LAMP stacks. It's kind of synonymous with pretty much PHP web servers as a general thing. Most of the security issues in Apache revolve around modules, as well as sort of patching and configuration, generally the staples of vulnerabilities. Most vulnerabilities, unless we're dropping a 0 day, are probably down to a missing patch or a misconfiguration. That's just the way it is. But in Apache, we're looking at the modules in particular. It allows us to use modules to extend its functionality. So for example, PHP isn't actually directly supported out of the box. That's a module that you can enable or disable. It's also got lots of other modules, for example, one that creates per user HTML directories on a system, and many, many more. So when we're looking at an Apache server, or any web server really, there are a few areas that we should be looking at. We should be looking at the file system permissions. For example, can other people write to the web root directory? We should be looking for process execution. Is Apache itself running as root? Historically it used to. These days it should be running as a user called www.data. And we should be looking at trying to restrict what modules are supported and what languages are supported and so on. So let's say we are running on a system, we're running as a low privilege user on this Ubuntu system called foo, having got a low privilege compromise. Instead of the compromise I just showed you where we ended up with root, we've landed as a user that doesn't really have permissions to do very much. But we've got a file here called secret.txt, which is owned by www.data. So we're going to try and gain access to it. So we can have a look at the mods enabled directory for Apache 2. This should be publicly readable. Any user on the system will be able to read this. And we can see that we've got user.conf set up, which appears to set up a public HTML directory in each user's home directory. And if we make a public HTML directory, we can prove that we can browse to that. It's exposed on the web server on that host. Which means, for example, I could create a symbolic list to the root of the, symbolic link to the root of the file system, make the whole file system visible to that web server. What if I wanted to get a full shell as www.data? Well, I can use some features and abuse those. So for example, PHP has a function called putenv. That allows PHP to set environment variables. Doesn't sound particularly dangerous, sounds like a reasonable thing to do. But there's one particular environment variable that's of interest to me, which is called LD preload. What it does is it allows me to override function calls when I load in DLLs. So as a developer, you would use this if you wanted to load in a common library, but you wanted to override a specific feature of that library with your own version. You could do so by setting LD preload and compiling a shared object containing your version of that function. Interestingly, the PHP mail function on a Unix host spawns a new process and passes on arguments. There are very few functions within PHP that do it, but this particular one, on Unix at least, spawns a new process. So as you can see, we've got a file called mail.php and we've stuck in PHP, called the mail function, stuck some junk in, and then we run an strace on it when it runs. And we can see that it runs a whole bunch of functions. It does a get UID, get GID, get PID, get EUID, and so on, because it wants to know who you're running as so that it knows whose mail to send. So I can create my public HTML directory and I can start trying to put some code in there. So I'm going to create a hook.c file with some C code, which sets LD preload, kind of went by a bit fast, didn't it? See if I can come back to that. It checks if LD preload is set. If it's not set, it drops us out. If it is set, it unsets it to get us out of any loops, and then it runs a system command which sends us, this is a reverse shell one-liner that you can find on the internet. Highly recommend Pentest Monkey if you're looking for a resource. This little run one-liner run on a victim system will result in it reaching out to our listener on our host on port 7777. So we'll save that and we'll compile it using GCC, natively present compiler. And then we're going to create a an index.php, which does putenv, sets LD preload to that hook I just created, and then runs mail with some junk. And that's literally all I have to do. I can then set up a listener. And I can refresh that page, and we can see that immediately it's connected out to me. It's set LD preload to my hook. It's attempted to run mail, which has caused my hook to be loaded, which has caused my fake get UID function to be run, which has resulted in me getting a callback from that host. And I'm now running as the user www data on our victim. Moving on to containers next, kind of hot topic, I suppose, for the last few years. Looking at Docker specifically, so Docker generally runs as a service with elevated privileges. There is such a thing as rootless Docker. It has its use cases, but it also has its unusable cases. So you will very frequently find that Docker is still running with elevated privileges. And the way it works is it downloads a Docker image, whether that's from the public hub, Docker hub, or from your own private repositories. And that image is a set of options, a set of code, which is executed line by line. Each layer is created by a line, and at the end you have a container. Now you can mount part of the you can mount part of the host file system to make it accessible inside the container. Now, obviously, you wouldn't intentionally do this as a legitimate user, but as a non-legitimate user that gains access to a host running Docker, we could potentially use this as a privilege escalation technique. You also may find that images that you see may expose ports, whether that's to the external network or to other containers on an internal network that Docker provides for all containers on the same host. And by default, the UID you have on the host actually matches the UID you have in the container. So Docker does use things called namespaces to provide isolation between processes running inside and outside the container. It uses things like troop jailing to separate you out file system wise. There's lots of things in place that are meant to prevent you breaking out of your container. But if you are running as root in the container, you are technically root on the base box, which means if as a malicious attacker, you deliberately share part of the file system, for example, here we've done a -v, which bind mounts a volume, and we've mounted / as in the root of the host file system, to a folder inside our container called /host. So that means we'll launch our container, we'll be in the root of the container file system, and we'll be able to see a directory called /host, which actually through a bit of sort of volumeception shows us the host file system outside of a container. Alpine, if you're not familiar, is just a sort of a lightweight container that we often use. And then inside the container, we can mess about with that /host. We can access files in there. We can use troop jailing to get us back out and so on. So how do we access it? Well, there's the Docker daemon. If the Docker daemon is not accessible because you need privileges to access it, maybe the Docker socket will help. It's basically access to the Docker daemon, but over TCP. So very often listening on port 2375 or 2376 if it's encrypted. And it's basically intended as a way of interacting with your container applications. But if it's misconfigured, it's exposed, whether that's intentional or otherwise, that could be a compromise of your Docker system and potentially your entire underlying host. There's a video there, by the way, if you want to see more on how all this stuff works. But I'm just going to give you a really quick demonstration of one angle here. So I'm back in as foo here on that system. I could do this as any user on this system, to be fair. And I attempt to interact with Docker using the Docker client, Docker PS, that interacts with the local Docker daemon. And I get permission denied because, in fact, I am not, as this foo user, a member of the Docker group. However, if I run netstat, I can see that this machine is listening only on localhost. This isn't exposed to the network, but on localhost, it is listening on port 2375. And what that means is I can just point Docker at localhost, and I'm now allowed to interact. There were no images running, And when I attempted to run Alpine, I actually found I didn't have access to the Docker repository. But when I run Docker images, it turns out there is one locally stored image. I can see using ps-a that it actually was running, but it was exited a couple of weeks ago. So I can attempt to run that image instead. Using the exact vulnerable code that I was talking about, I deliberately mount the host root to /host inside the container, and you can see I'm running as root in the container. If I cat out proc1 cgroup, it kind of gives away the fact that it's Docker, in case I wasn't sure. So in case you ever land on a Docker host and you don't really know. And if I cat out the contents for ls, the contents of /host, I am most certainly looking at the host file system. So why not just add myself as an SSH user as root on the host file system, drop back out of my container where I'm root, drop back out to my own machine, and now SSH in as root to that host, just like that. Whoops, started that one again. Okay, so let's say we land on a Windows system then. Take another slight change in direction. And we're going to face a few different restrictions. So for example, introduced in Windows 7 Enterprise, now standard in Windows 10, is a tool called AppLocker, which advances the application control features and functionality of your software restriction policies. It effectively adds on a bunch of additional restrictions you can apply, rules for allowing and denying access to things to your existing group policy abilities. So those rules can control who can access what applications, what scripts, what installers, what DLLs, what packaged apps, based on the publisher of that file, the path of that file, or the file hash of that file. And you can set up allow or deny actions for these based on users and or groups of users. So here we go. We've set up so that you can't run. This is sort of the default settings you'll have. You can't write to program files x86 and Windows directories. And then you set it up so that you can only execute files, binaries that are in those locations. So if I download the portable PuTTY executable, I can't run it from C users alice downloads putty.exe on this compromised host. But if I'm able to perform an AppLocker bypass check, in this instance, we've found that a misconfigured driver has set C Windows System32 spool driver's color as a writable location. I copy that PuTTY executable to that location, and all of a sudden it will run. It's as simple as that, based on path-based restrictions. And then if I find a misconfigured permission on a directory, that is a path to execution. What if we need to find a way around some of these restrictions in a bit more of a clever way? There's some research by a guy called Casey Smith a few years back, where basically one of the restrictions you'll probably find you have in place on a victim machine is you can't just install stuff as any old user. Generally speaking, the install function requires privileges, but the uninstall function very often does not. Uninstalling stuff doesn't seem like it can do any harm. The question is, can you uninstall something that was never installed in the first place? And the answer, in case you're wondering, is yes, you can. And what we can actually do is we can create a C# program, which is what we're going to do, with an entry point that overwrites the standard uninstall behavior of this application that we're never going to install. We write some C# code in our uninstall function, which will call in our own PowerShell script and execute it in a pipeline without ever running PowerShell, because we're going to have restrictions on this machine that won't even run that. We compile it using a local compiler, the C# command line compiler that's included with .NET Framework. We're then going to use the install-util.exe with a /u to run that. Sounds mental. This generally gets sort of, wow, this looks like black magic kind of responses out of people. So I've got some tools on my Kali host that I'm attacking from in this instance, and I've got execute.cs, which is some C# script that I'm going to use. So I'm just going to serve this from my Kali host using a simple Python HTTP server. What that means is I can retrieve my attacking tools from my compromised Windows host. So on this host, as a very low privilege user, I'm not allowed to do anything. I'm not allowed to launch executables. I'm not allowed to run PowerShell or CMD or anything. Pretty much all I can do is get to my downloads folder and launch Edge. But from Edge, I can browse to my attacking machine that I've made available over the internet. And I'm going to grab my execute.cs file, save it locally, and I'm going to have a look at that inside Notepad++ because it gives me a little bit of syntax highlighting. And you can see that we've got an override of the function uninstall The main method does nothing. If you're familiar with C coding of any kind, you know you need a method called main. That's what is run when you execute the compiled executable. It won't compile without one, but as you can see, it does nothing. It's empty. We've created, we've used the run installer, system component model run installer to override the uninstall function. And with a call to mycode.exec, we've then created the mycode class, the exec function, and it's going to read in, didn't get quite fast enough. It's going to read in a file, C users Bob downloads commands.ps1. We're going to create that file, which is going to run a few system functions, and it's going to output those to a text file for us. Now we're going to find I can't browse to the C directory. I can't do anything on this system. I'm very, very restricted. However, if I start messing about with shortcuts, it turns out I can actually make a shortcut to C, and I'm allowed to use that. All of a sudden, I can have a look through Windows, Microsoft.NET, and find myself that csc.exe and my install util.exe. So let's create some shortcuts to those. And I'm just going to take this and show you it in a text editor. Basically, it calls, maybe I won't, it calls csc.exe, loads in system management automation, which is the underlying PowerShell libraries, and runs a compile unsafe, and it's going to output it as a file called runme.exe in my downloads folder. Now, of course, when I compile this, I'm not going to be able to run it. I'd normally do this. This is a command line compiler, by the way, but I'd normally do this from the command line. But what I can do, because I can't access command line, is drag that CS onto it, and it will say open with Visual C# command line compiler, and that will literally feed that to it, and there it is. It's compiled. But I can't run it. Of course I can't. It's an executable. So I'm going to need to follow this up with another shortcut, this time to install util.exe with the /u switch, which is the most important part. And then same trick, I drag runme onto install util, and as you can see, it's created command out.txt, which contains the output of all of these commands I ran. Pretty clever stuff. As I say, kind of black magic, isn't it? We might come across some other restrictions. So I'm going to skip ahead a little bit. We've actually already privested on this system, but we may come up against AV products when we start trying to do more advanced post-exploitation. For example, one of the first things I'd want to do probably on a Windows system is grab Mimikatz. Mimikatz is going to be picked up by most AV. There are some tricks we can perform. We can add exclusions. We can kill off the AV service completely. We could run code from memory potentially on historic systems, or use script payloads instead of executables, or we could use tools like veil evasion and shelter to hide inside legitimate binaries. Really quick aside on Cylance AI-based or machine learning-based AV, the way it works is by using a trained model data set that is that's trained on the malicious behavior of binaries rather than basing it on the signatures of known bad files. And it turns out you can ask it what its scoring logic is, and it will tell you what the output is. So some researchers were looking at this, and they discovered a very straightforward exception that had been put in place. What had happened was there was a game which was crashing the deep scan. People were complaining because they paid for the game, they paid for Cylance, they wanted to be able to play the game, simple as that. So it turns out this is common behavior, common practice in the AV industry. When there's a false positive or an error that comes up like this, they just exempt it by grabbing some strings from the start of the binary, looking for those strings. If it sees them, it skips the checks, it skips the deep scan. So we could put the same strings at the start of known malware, and you can see its scans go from very, very high negative numbers to very, very high positive numbers. That's the only change that we made. Back to the real world, and AV didn't used to be that smart until a thing called AMSI was introduced by Microsoft. So it's an anti-malware vendor agnostic tool that basically allows our common malware scanning protection techniques to be extended and integrated so that we can, for example, run file and memory or stream scanning. Historically, running code from memory used to prevent it from getting scanned. It didn't touch the disk, it didn't get scanned. Now we can scan memory and stream. We can check content source, URL and IP reputation checks, and all sorts of other tricks and cruel ways of preventing me. Now, again, we could turn it off. We could just disable. If we're a local admin, we can do that. But again, that's probably quite loud. And also, what if we actually needed to bypass AMSI in the first place? You might be able to use the PowerShell version 2 because it doesn't support AMSI, so it will just skip it. But actually, on a default Windows 10 installation, PowerShell 2 is long since not there. But there are a few tricks. There's a tool called the null character. Stick a null character at the start of a file, and AMSI will treat that as the end of file and will stop scanning. Null characters, by the way, been around for a very long time. Quite a well-known vulnerability in PHP back in like PHP, I don't know, 5. Long since deprecated, very, very old vulnerabilities, but turns out these things refuse to die, and you'll always find it somewhere. We could potentially manipulate the code, change the name of the script, remove comments. If it's just signature-based scanning, that might be enough to bypass. We could use tricks like Frida. You could use a write-up here on disabling AMSI and JScript, or we can use one of these rather neat one-liners where we retrieve the system management automation AMSI utils, and we look for a field called AMSI init failed. You can probably guess what it does. Set that to true, and it's like a Jedi mind trick on AMSI. You just wave your hand and say you failed, and AMSI goes, I did fail, and I want to fail gracefully, so carry on, move along. This one does much the same thing. It just sets the context of it to some junk in memory. It goes off and scans it, and of course a string of A's is never going to be malicious. Or indeed you could drop your own custom DLLs on top of AMSI.dll and get it to do whatever you want it to do. So here's a quick example of that. I want to run invoke Mimikatz. I try and run it in PowerShell. You can see I'm falling behind already. And I'm going to use a trick that historically would have worked. This is going to load it straight into memory. However, I get not recognized. Not it's malicious, but just not recognized. And that's because it never makes it to the point of trying to run it. It's caught by Windows Defender thanks to AMSI before it even gets there. However, if I set AMSI to failed and run the same command, eventually, there it goes. Mimikatz has run, and if I run through all of that output, you actually will find some credentials for a user. Now, we started demonstrating this at Black Hat a few years ago, and after a year or so, someone said, actually, they fixed it in a newer version of Windows. Your lab's out of date. So we thought they might have us there, and we did some research. And it turns out they'd implemented a fix that basically looked for AMSI utils, AMSI init failed as strings, and rejected them, called them malicious. Literally, this script contains malicious content. It's this command that we ran. This doesn't even attempt to load in AMSI. It's literally running that command. Mimikatz running this command does nothing malicious, but the fact that it calls AMSI utils and sets AMSI init failed to true makes it a malicious script. But it turns out you can just concatenate. This is one of the oldest tricks in the book from the sort of the early days of trying to fix XSS on websites. They'd look for script tags, and so we started concatenating our script tags, and we just put AMSI utils instead of AMSI utils, and that's enough to bypass. You can see that it doesn't come up with an error when we do that. So we're on a system. We're already at this point high privileges. Let's talk persistence. So Mimikatz, among its sort of initial credential extraction tools and the various other tools it's got a tool called DCSync, which you can actually use to impersonate a domain controller. It's a passive attack. It does this without running code on the actual DC. But if we successfully run a rogue domain controller, we can potentially use it to gain access to your user's password hash history. We need to be a domain admin to do this. So this is sort of a post-exploitation after you've got domain admin kind of an attack. But we can, for example, we've got Mimikatz running on the system here. I load it up and I run DCSync on the user God mode in this example. And we've got the last 30 password hashes for that user God mode. We've also got a user Jenny on this system where, as domain admin, we've gone in and made a registry change on the domain controller, which enables a thing called reversible encryption for user passwords. You can probably guess where this is going. The next time Jenny changes their password, we've now got their clear text password being dumped out by DCSync. Last but not least, we're going to look quickly at cloud compromise. So within cloud, it is infrastructure, and so we kind of in many ways treat it as infrastructure that's no different to others, especially if you're using sort of EC2s, sort of basically VMs, but in the cloud. But one of the big differences is there's an API layer called the Metadata API, which the cloud providers give you to access system and environment information from inside cloud services. So they've all got one, and in fact, there are ways in which they're very similar. They've all agreed to work over what would normally be a non-routable IP address, 169.254.169.254. Try and access that from a regular machine, it will come back as not routable. From inside a cloud service, it should interact with the metadata API, and you can send HTTP requests to that metadata API, and it will give back information. Now, the actual features will vary significantly, but basically, from GCP, you can send a query. You'll need to provide a header in order to get a response. This is a protection against reflected attacks like SSRF, server-side request forgery. You go to metadata.google.internal, which, by the way, does resolve to that 169.254, 169.254. Compute metadata, version 1, instance, service accounts, the name of the role you want, token, and that is a token that you can use to configure, for example, your command line tools to interact with the management APIs as the user, as the role that is assigned to the service you're inside. Similar for Azure, you just need to provide some slightly different parameters, different header, you need to add a version and stuff like that. From AWS, they used to have, they used to just have instance metadata service version 1. They got sued in November 2019 because GCP and Azure required metadata flavor type headers. They required headers in the attack, in the request in order to prevent reflected attacks. AWS did not. You could just send this request straight up, which allowed reflected attacks against the API. Technically, GCP also had the same issue because they had version 1 beta 1 also valid at the time, but that was being deprecated, whereas AWS hadn't replaced IMDS v1. In response to being sued, IMDS v2, Instance Metadata Service version 2, came along, which now requires a header. And in fact, the process is slightly more complicated. You have to retrieve a token first by sending a put request rather than a get request to an endpoint with a header, and then feed that token as part of your ongoing request. So yeah, that's a reaction and a half. Now, if we look at a few specific kind of scenarios, function as a service, or Lambda on AWS, as you're probably all familiar. GCP and Azure just call it functions because they lack imagination, I think, but there we go. OWASP have done an interpretation of their OWASP web application vulnerabilities top 10, one of their most well-known projects. They've done an interpretation specifically for serverless. By the way, I hate that term. It's function as a service. Now, both Google Cloud Functions and Azure Functions are allowed to interact with their metadata APIs from inside a function. Lambda actually doesn't have access to the metadata API. However, access tokens will be in environment variables instead, which just makes it a slightly different attack. If we manage to extract some tokens, we need to figure out what they can do, what services are accessible to the roles that we've gained from whatever service it is that we've just compromised. So what IAM capabilities we might be able to use, what service entities we're allowed to interact with. Now, the cloud vendors have absolutely massive APIs. We're allowed to send all sorts of queries. Now, we initially thought that we could just use audit software, repurpose it using our token, and just sift through the access denied responses until we find ones that actually do something. But it was a bit too messy. So instead, we needed a better approach to enumerate permissions on stolen keys. We wanted to automate it because, as I say, the APIs are enormous. So we ended up building a suite of cloud enumeration scripts, which are yours to take away if you would like. So you can read a read up in our blog on our website, and you can grab our code from our public GitHub repository. And you can use these to explore the permissions on any given AWS, Azure, or GCP temporary security token. So let's say I'm attacking, this is a deliberately vulnerable service we've set up. You can actually have a look at this yourselves as well. It's at tester.notsofruity.com. I don't know why I've blanked that out. You type a command in, you run it, and it shows you what response you get, both from AWS and GCP. So I typed ID, and you can see that I'm running as root on G-Cloud or a user on AWS, because serverless, by the way, runs inside a Docker container. That's how it works. I've then run a curl request to 169.254, 169.254. As I mentioned, Lambda doesn't have access to the metadata API. However, G-Cloud, we can start exploring. So compute metadata, I can put that in. V1, I can put that in. And you can actually go further with that if you wish. So it says missing required header, metadata flavor. I can modify this command with a +H, well, a -H to add a header, metadata flavor, and carry on exploring. On AWS, if I type set, that prints out my environment variables. And as we can see, we've got a secret access key, we've got an access key ID, and we've got a session token. And that's all we need to configure our command line tools. So here's a vulnerable service. Whatever I type in here gets reflected back, unless I add a semicolon, in which case it doesn't. There's clearly some kind of command passing. Let's figure out what it does. Turns out that if I just tell it to print out variables, I can get it to show me who it is, what its environment variables are, and so on. So I can take them offline and have a bit of a play. Let's hop over to a terminal eventually. There we go. So I'm going to retrieve our cloud service enum.git. I'm going to go into the AWS service enum directory, and I'm going to run Python AWS service enum.py, feeding in the access key, secret access key, and session token and region that we've just established from this victim function. And we can see that we've got some buckets exposed, S3 buckets, various other things. So if I then configure my actual command line tools, so I'm going to export these environment variables, AWS configure, which is what you'd normally use, doesn't work with session tokens. So if we're attacking a temporary security token rather than a legitimate user account, we have to export them instead. So let's grab all of those. And then we should be able to run the AWS command line tool, and we can say, for example, S3 API list buckets, and it comes back because we are legitimately running as that user now. And we can then explore those and find out where to go with those. For example, copy these files locally and start attacking other systems. So huge amount, I'm slightly behind, huge amount to give you, but I now get to pass back and catch my breath.
Thanks for Anthony, that was brilliant. And also a big thanks to everyone who's got to this point. I appreciate that there's actually been not many people dropping off, so that's a great sign. It shows it's been a thoroughly informative session. So thank you to Anthony and thank you to everyone. Just before we wrap things up, I've just got a couple of training dates that specifically refer to the hours brief snippet, if you want to call it that, that we've just witnessed. So the next couple of courses, depending on the region or geographical place that you may be, are on the screen now with a specific discount code. And then I think the next couple of slides, we've got some upcoming training dates as well for other courses that may be of interest. As you can see there, certain courses running from UK time and then also US time as well. And then I believe there's one webinar next week around DevSecOps, and then that will be a bit of a short break in the interim just until we get through to June, July. Yeah, I think we've had a couple of questions. So just ever so quickly, oh, that reminds me, the webinar prize draw that I quite rightly mentioned I would explain a little bit about at the start. So all we need to do to enter is email that email address at the bottom there, contact@NotSoSecure. It can be a inquiry about anything you wish, really, within reason, preferably around a training or pen test requirement. If you have a generic question around security, feel free to email us in. We've also got a contact page on our website as well, where you can submit an inquiry via a web form. We've had two questions come in, Anthony, so ever so quickly we can go through them. It shouldn't take any more than a couple of minutes, hopefully. The first question is, what's the prior or prerequisites needed for the course?
Brilliant. Okay, yeah, so obviously people are going to start dropping off, but that's all right, I don't mind. Just trying to answer these as quick as I can. Basically, to get onto the course, it would be handy if you have some decent knowledge of how to work, for example, with Linux command lines and stuff like that. It is an advanced course and it does go at a hell of a pace, but as long as you are reasonably technically minded, you should be all good. If you have concerns, you know, go for one of the earlier courses. Either start off on the 101 or go with the sort of basic or intermediate, I would probably call it, infrastructure hacking course. And then to actually sit the course, basically you just need a laptop. You'll need admin access on it because we configure an open VPN to connect, but other than that, it's yourself and a willingness to plow into some really terrifying techniques.
Brilliant. And then finally, it's just one live question that's come in regarding serialization and actually how serious is it?
So I get this one a bit because we introduce it and it sounds like it's a bit crazy theoretical, right? To be clear, it started off with this one technique, and as I said, no one took it seriously for like 11 months nearly, until someone released a proof of concept and demonstrated just how easy it is to attack. And this was on live servers for, as I think I mentioned at the time, like WebSphere, WebLogic, JBoss, so many really important and sort of core enterprise applications that are in use. From then, it's been found, as I said at the time, in so many different places. And just to give you sort of one of the most ridiculous, just to give you the ease with which it can sometimes be exploited, there is a content management system called Joomla. I guess you could liken it to WordPress if you're not familiar with CMS systems. And you can send a request to a Joomla host from, I think this one was found in October, November 2015. So it's going back a bit, but you just sent a request with some code in a header, any header. Didn't need to be serialized, didn't need to do anything special. Just overwrite your user agent header from your browser, for example, with some code, and that code will get run on the victim system. It was as easy as that. And as I say, we're still finding these. This is not a vulnerability that's dying off anytime soon. They're still recently being found in Microsoft Com, in Docker, in fact, all sorts of places. This stuff is still being found.
Brilliant. We've actually that's perfect, Anthony. Thank you. We have had a couple more come in. I'm really conscious of time, so what we'll do is we'll email you all individually with regards to those questions. So thank you for those, though. We do appreciate them. So that's it from us. Again, a huge thank you for your time. If you do have any questions whatsoever, please do feel free to reach out. We really do want to help you, whatever it might be. We've hopefully got something that can be of interest to you. If we hopefully we'll see you, I think it's next week for the final webinar of the series. And yeah, wherever you are in the world, have a great evening, good morning, and thank you again once for joining.
Thank you very much, everyone.